In this Why Plastic Parts Fail, let's take a look at a roller made of PSU or polysulfone. The OEM reported cracking failures of the roller prior to service a few days after machining. Polysulfone is considered an advanced thermoplastic with very good temperature resistance and a light amber translucent appearance. This translucency is a hint that polysulfone is an amorphous thermoplastic. Unfortunately, amorphous thermoplastics are known to have reduced chemical resistance compared to semi-crystalline thermoplastics. In this case, the PSU roller was machined from stock shape rod and a traditional metalworking coolant was used. Standard coolants contain rust inhibitors, sometimes identified on the safety data sheets as chemicals with the suffix amines. These amines often attack amorphous materials like PSU, leading to cracking or crazing of the material. Cracks often first appear near areas of high stress concentration, like sharp 90-degree angles or corners, or even at machine threads. The chemical attack may not be visible immediately, and actual cracking may take a few days to occur, as seen by this OEM. While the OEM could have directed their machine shop to use an appropriate water-soluble coolant safe for the amorphous polysulfone to eliminate the cracking, because the application is a roller that requires excellent wear performance, a semi-crystalline FDA-compliant thermoplastic like nylon, acetal, or PEEK was recommended. While amorphous see-through materials are excellent for many applications, including where clarity is desired, if your application involves exposure to aggressive chemicals and/or for any wear applications, one should consider the use of semi-crystalline polymers to achieve the best performance. Please feel free to add your comments below, like and share this video if you found it helpful, and subscribe to our YouTube channel. Thanks for watching.